you, Beth. It's really wonderful to be back here. Last time I was here, I was talking about basically an apocalypse brought on by viruses. We'll have a nicer time tonight because we're going to talk about families and where we come from and all of that. I enjoyed very much watching Flirting with Disaster, just sort of a bit of homework for my talk. I had actually seen it when it came out in 1996. And I'm a big David O. Russell fan. This is one of his first movies. It was really interesting, though, watching it now as opposed to 1996. And I promise, I've taken a few screen grabs of the movie. No spoilers, I promise. But, just in case you don't know anything about the movie, Ben Stiller is playing this father who he's about to become he's a new father. And the whole movie kind of turns on him not being able to give his son a name. And he says, I've just been distracted in tents. And I get that now watching that, because after I watched the movie was when I became a father. And so that's my daughter Charlotte, and that's me just trying to stay awake. Charlotte's now 17. She's doing great. But at the time when my wife was pregnant, we went to see a genetics counselor, and she just started asking me about family history, about my ancestors, and was there anything maybe we should be concerned about when it comes to this child that we were bringing into the world. And I got very anxious and tense, because suddenly I realized I don't know anything about my ancestry. I don't know what I've inherited from my ancestors. I have no idea what it is that I'm passing down to my kids. And it was a very stressful thing, because it kind of put me smack in the face with the importance of heredity for how we define ourselves and how we situate ourselves between the past and the future. Now, that's something that I talk a lot about in She Has Her Mother's Laugh, and so it was a real pleasure to be able to come here and talk about this movie, which really resonates in a lot of ways with the things I've been thinking about. Now, watching this movie now in 2019, you notice things about a movie made in 1996. So there's Tia Leone, and what is she holding? I mean, it's not very far from Get Smart, I have to say. And it reminds you how, 1996, maybe for some of you it doesn't seem that long ago, but a lot has changed. And actually that's really interesting when it comes to this movie, because, what the character that Ben Stiller plays wants to do is to sort of finally, he says, okay, I'm adopted, and so I need to, find out who my family is. And again, this is I'm giving you the first minute of the movie, all right? So don't hold it against me. But when you watch this movie, think about the weight that he's putting on this discovery process, and actually talking with someone who's going to connect him with his parents, his biological parents. The woman off screen says, well, the mystery of your unknown self is about to unfold. That's heavy. I mean, that's how we use heredity to define ourselves. And that's he has this sort of deep hole that he wants to fill with understanding where he comes from. But how do they talk about that connection? Well, you'll see that there'll be these lines well, we have the same forehead, don't we? In 2019, if you're talking about looking for your biological parents, that seems a little old-fashioned. You will not, this is a spoiler, you will not hear the word DNA in this movie. I found the script online, it's not there. And that's because, the way that we now all talk about heredity, about family in terms of DNA, it's a very new thing, and it's brought about by science, very recent science. Now, that doesn't mean that people haven't been really obsessed with heredity for a long, long time. It is the stuff of literature going way back. Okay, so we can talk about Oedipus, who had a kind of unfortunate discovery about his family. If he had a DNA test, things might have worked out differently. Oliver Twist, think about Oliver. The whole gist of the story, again, spoiler, is that he is this lost child, and the plot arc reunites him and shows who he really is and who his parents are. And that connection is the climax of the book. These are all stories that don't rely on a DNA test, and neither does Flirting with Disaster. That doesn't mean that the people weren't struggling to figure out who their ancestors were. I mean, the problem is that people had no genetic way of establishing it. So it's actually kind of fascinating if you look back. Well, how if people were in some sort of dispute, I mean, how would they resolve it if they couldn't look at DNA? In the courts of Rome, they had this principle. In Latin, it's called pater est quem nuptiae demonstrant, which basically translates to the father is the one whom marriage points out. That's it. Do we have any disagreement here? Like, are you married? Okay, you're the father. In 1304 in England, there was a court case where a man had gone off to sea for 3 years. He comes back home, and his wife has a baby. So he goes to court and says, "This is not my child." The court actually decided in the wife's favor, based on this principle. And the judge said that the privity between a man and his wife cannot be known. So that's it. And the reason I'm showing you a bald eagle here, you might be wondering, is that actually there came to be a principle that was based on what a kid looked like. So did a kid look like his or her parents? And if the answer to the judge was yes, that's good enough. And this actually became known as the bald eagle evidence. Because if something looks like a bald eagle, it probably is a bald eagle. And I'm not kidding. You can Google this. Bald eagle evidence. There was a judge in 1769 who said, "I have always considered likeness as an argument of a child being son of a parent. For in everything there is a resemblance as of features, size, attitude, and action." So these judges were taking a lot of liberties in order to figure out who was family, who was who. How do you connect children to parents? And this actually extended into the 20th century, even after genetics was starting to change how we think about heredity and how we recognize heredity. And what's kind of neat to talk about this tonight, when we're going to watch a movie, is that a great movie star actually is kind of pivotal in this history. So Charlie Chaplin, in 1942, he had an affair with a woman named Joan Barry. He abandoned her, and she was pregnant. And she gave birth to a child she named Carol Ann, and she took him to court saying that he was the father. And there were actually two cases. One was a criminal court case, and then one was a civil suit. He won the criminal case, but in the civil suit, he decided what he was going to do was he was going to introduce what should have been incontrovertible evidence that he was not the father. his blood. So in the 1940s, I mean, people couldn't sequence DNA yet. They didn't even really know that DNA was the stuff of genes, but they knew that the proteins on our blood cells are very strongly inherited. And actually, you can use really simple laws that you learn about in high school to figure out blood type. So A is dominant over O, B is dominant over O. So one thing that tells you is that if a child, for example, is a type B, then a parent who is type O cannot be the father or mother. And it turned out that Charlie Chaplin's type O and the child was type B, and so it was impossible. It was literally impossible that this could be the case. This was actually one of the first cases where blood type was used as evidence in court in terms of deciding who was a parent of a child. And you might think, like, well, that was it. Okay, we're done. Actually, the jury, the lawyer said, well, look at this kid. She looks just like him. Bald eagle evidence. And the jury said, yep. They found in Joan Barry's favor, and Chaplin had to pay $82,000 in total in child support for this child who clearly was not his child. And this is not to defend how he treated this woman. Chaplin was pretty horrible to his girlfriends, but the fact was that this wasn't his child. And the Boston Herald, I suppose, looking across the country at California, was horrified. And they wrote, California has in effect decided that black is white, 2 and 2 are 5, and up is down. This was actually the end of Chaplin's American career. He left and didn't come back. And California actually very quickly changed their laws to make it clear that this kind of blood type test should be considered very seriously in these kinds of disputes. But that was a very simple way of trying to figure out who's a parent. And basically, all it can really do is say who is not a parent. You can say Charlie Chaplin could not be this child's parent. It's a very different thing to say this person is this person's parent. But DNA, once scientists started to learn how to sequence it and compare it between people, that started to give clues about families. And just a real quick reminder, DNA is this double helix, which is basically a big cookbook spelled out in letters from a 4-letter alphabet. These are the base pairs that I'm showing you there. And you have 3 billion or so pairs of these bases. And, if we were to pick, 2 of you at random, you pretty much have identical DNA. Maybe 1 in 1,000 places the letters would be different. And if we printed it all out, as this person did, as quite a masochist, this is how many books it would turn into. So there's a huge amount of information there that you can look at if you have the technology to tell people apart. Now, in the 1990s, it was still very difficult and very, very expensive to sequence DNA, and so scientists could only sequence little fragments of it. But that was enough to actually to answer some interesting mysteries. This is Tsar Nikolas and his family. In 1917, they were captured by the Soviets during the Russian Revolution and disappeared. It was very mysterious. People assumed that they had been massacred, but nobody knew what had happened to them. And there were a lot of stories, which turned into another movie, about what happened to one of the children, Anastasia. And there were lots and lots of women who come forward and say, I'm Anastasia. How can we know? Well, scientists in the early 1990s, they were able to take little fragments of DNA and to start to get some clues. And they could see from these fragments, I'm sorry, I skipped the most important part, sorry. In the 1970s, someone dug up a pit and found a bunch of bones. And this was near where it was believed that the Tsar's family had been taken prisoner. So the idea was, well, maybe this is the Tsar's family. And so it turned out there were bits of DNA still in the bone. And so they could look at the DNA, and they could look at little fragments. And there was enough to tell them that this was a family, because they could tie the children's bones to the adult bones. There are two adults in the grave. And then later, what they were actually able to do is say, like, well, you know, the Tsar's family was very closely related to other European royalty, including Prince Philip. And so they actually got blood from Prince Philip and other European nobility, and they were able to say, like, this is a royal family. This is a family that's related to Prince Philip on one side, to other nobility on the other side. So it's pretty clear that that the bones of the Romanovs, of Tsar Nikolas and his family, have been found. But again, you know, this is in the 1990s. This was something you would only do in a super special case. I mean, you know, your family had to be a royal family for scientists to spend this kind of effort to figure this out. And things have changed incredibly since then. This is a graph that shows you how much it costs to sequence a genome. That's all your DNA in a cell, like all 3 billion base pairs. The first genome, which was sequenced in the 1990s, cost around $2.7 billion to do. By 2001, that had fallen to $100 million. And you know, this graph is actually, you got to bear in mind, this is a logarithmic graph. We're going from 100 million to 10 million to 1 million to 100,000. We're down in the corner here where it's around $1,000 now to sequence an entire human genome. It's an incredible crash. Moore's law across the top there, that's for microprocessors in computers. And computer scientists love to talk about Moore's law and how incredible it's been that the computing is so cheap. Sequencing DNA has totally put Moore's law to shame. And that's suddenly opened up DNA sequencing, not just to the Romanovs, but to every family. So, you know, we have here, this was on the Super Bowl. I mean, this is DNA testing, direct-to-consumer DNA testing on the Super Bowl. It has arrived. And so people are giving these kits out as Christmas presents. I don't know how many of you have gotten your DNA tested or given it as a gift, but this has taken off amazingly. I mean, this graph, just bear in mind, that graph starts in 2013, not that long ago, and it has been accelerating in terms of how many people have gotten their DNA tested. So we're above 26 million in 2019. In case you hadn't noticed, it's March. So this graph is going up to the moon. So the estimate is that by next year, 100 million people will have gotten their DNA tested. This is, I talk about this in the book, in the history of science and culture, this is unprecedented, that people are looking at their own DNA for the first time in huge numbers. So I took a look at my DNA. As Beth mentioned, I actually got my whole genome sequenced. My brother Ben, who Beth also mentioned, I think he used Ancestry, and got what's called genotyped, where you basically look at about 1 million bases scattered around your genome, and that gives you a good idea of how your DNA varies from other people's. And that was enough for us to compare our DNA. And so Ben, who was here not too long ago, shares a lot of DNA in common with me. So the red there are stretches of DNA that are identical in him and in me. And you don't get that unless you are really close family. So if I had any doubt that he was my brother, he's my brother. People say we don't look alike. We both write newspaper columns, so I don't know. I don't know what chromosome that's in. But I'm saying it is clear that we are brothers. And lots of people are using these services now to look for other people in these databases who have identical stretches of DNA. And so this can be a way for you to find some second cousin that you never knew about. And if you can tap into that second cousin's ancestry, like on one of these genealogy websites, all of a sudden, like, you get to know about your own family in a much deeper way. And for a lot of people, this has been a really, wonderful, powerful experience. That being said, there are some stories that are not so wonderful. In this month's Atlantic, Sarah Zhang, a really talented young reporter, has a fantastic story about a fertility doctor in Indiana who would have patients coming to him where the husband was infertile, and so he would supply them with sperm donors. It was all his sperm. And so there are dozens and dozens and dozens of people who are putting their DNA into these databases and suddenly discovering, oh, I've got a half sibling here and here and here and here and here. All of a sudden it turns out that they have all these relatives, family, very close family they had no idea about. And I just as a side note, I mean, if David Russell is interested in a follow-up to Flirting with Disaster, he's got to make a movie about this guy. This guy is crazy in a perfect David O. Russell way. Anyway, it's a great story. Now, it's one thing to sort of say, like, well, who is my mother, who's my father, but they, in a way, it doesn't stop there. Knowing who your parents are is like a portal into the past, into the deep past. So you can find out, are you related? Are you an ancestor of someone interesting? We love to find out they're related to someone interesting. It's sort of, in a way, it kind of makes us interesting, as if it is passed down with our DNA. So maybe you descend from a Confederate general. Maybe that doesn't make you so happy, or maybe you don't. Genealogy and this way of looking to the past to justify yourself is a very old art form. In the Middle Ages, kings basically invented genealogy as we know it, and they were using it as a way to justify their power. And most of these family trees would end up at King David. Somehow every king in Europe was descended directly from King David, and that was part of their justification for being an absolute monarch. In the United States, we're a democracy. We don't care about that so much. We're above all that, right? Actually, we're not. So here's Ancestry with one of their ads, and these people know how to do ads. You've got to give them credit. So it's very exciting you can use your DNA to connect yourself to family trees where other people have done the research. So if you don't really know who your ancestors are, you tap into these genealogies and they'll say, like, hey, guess what? You are related to George Washington. Maybe you're descended from him. And this is really exciting. I mean, look at the smile on her face. She is so happy to discover that she's not even descended from it. She has this ancestor who is George Washington's aunt. Okay, so she is like a distant cousin of George Washington, but that's good enough that she's going to hug that picture. It somehow, like, something is coming off of the picture to her because of this connection. My family is, like many families, is really into genealogy, and the only person who's at all notable that I can point to is this guy in the water. His name is John Howland. So John Howland came to the United States, the colonies, in the Mayflower. So that means I, if I wanted to, get to join the Mayflower Society because I'm special. John Howland fell out of the Mayflower. He was a servant. He was looking and slipped out. And I'm here to speak to you because some nice person on the Mayflower threw a rope out And he grabbed onto it and survived. And so I actually get to be, if I wanted to enroll in another society. There is actually a John Howland Society. Now, I don't know what's special about us, like we're good at holding onto ropes and water or something, I don't know. But it's not actually a very exclusive club. Someone did some back-of-the-envelope calculations. There are probably 2 million people in the United States who could, if they want to, be part of the John Howland Society. So think about how many people could be part of the Mayflower Society. So we looked at these periods of history and want to connect with them to make ourselves personally have a special frisson. I don't know. But the fact is that the way genealogy works is that if you go back far enough, something very interesting happens in genealogy. You know, your parents, this goes for everybody, your parents are cousins. Not first cousins, maybe 10th, maybe 20th. But the fact is that if you were to trace the ancestry of your parents back far enough, you would go to a common ancestor. And mathematicians love this. This is like a big geometry problem for them. And it turns out that you don't have to go back very far to find someone who is a common ancestor of a huge number of people. So if you are of European descent and are alive today, so that would include a lot of you here, no corpses, I see. So you are a direct descendant of Charlemagne. I say that with complete certitude. We know actually that there are living descendants of Charlemagne because there's actually something called the Order of Charlemagne, and they've worked very hard to prove that they're descended from Charlemagne. And these mathematicians have shown that if you go back far enough, if somebody at a certain period of time has any living descendants, then all living descendants in a certain area are descended from that person. So thanks to the Order of Charlemagne, 1 billion people could claim descendancy from him. That doesn't mean that he's their only ancestor, of course. Everyone has thousands upon thousands of ancestors. But if you have European descent, be proud. You have Charlemagne in your ancestry. But what does that mean? What does it mean to have someone in your ancestry? We think about ancestry so much in terms of DNA now that it's easy to forget that DNA gets shuffled over generations after generations. It gets mixed together, and pieces of DNA kind of get lost in the process. And so if you were to look back at your ancestors, you inherit segments of DNA from them, and about half of those segments, well, exactly half, come from your parents. With your grandparents, about 25% come from each one of them. So you have some DNA from all of the ancestors. And it's true for your great-grandparents, although those segments are smaller when you go back there. But what's really interesting is if you go back about 8 generations, you will encounter ancestors, your direct ancestors, from whom you inherit no DNA at all. There's not enough room in your genome for all your ancestors. They sort of crowd each other out. And so by the time you get to generation 10, this is like my John Howland generation, it's actually less than half. The chances are less than half that I have any DNA from John Howland. So I still am very proud that somebody who couldn't even stay in a ship is my direct ancestor, but I probably don't have any DNA from him. And it gets worse from there. So all of you who I've just told are direct descendants of Charlemagne, you probably have 0 Charlemagne DNA. Sorry. So you have not actually inherited any Charlemagne gene, I'm sorry to say. So you need to think of your DNA as sort of a sampling of your ancestry rather than some sort of direct estate that gets passed down like a crown or a throne or something like that. DNA is much more complicated than that. So finally, the last thing I wanted to talk about in terms of DNA is, beyond going to George Washington or John Howland or someone else famous, we Americans in particular like to look at our DNA these days to kind of get clues about where our ancestors came from. And somehow, if we find out that we are, say, Scottish Finnish, like that is going to mean something. Like we have to kind of rethink what it means. Like what happens when you discover that you're Scottish Finnish? This is the kind of map that people get from places like Ancestry, and it's very detailed and seems to be very specific. Take these with a big, big grain of salt, because all they're doing for these things is they're looking at people who live in these different places and whose families have been there for a few generations. And they're saying, do you have a certain number of markers that are unusually common with them? And then they try to estimate this. The estimates get better as they look at more people, but there's been this problem recently where Ancestry gave out these results in the last few years, and people would get very excited because they would discover, like, oh, sure, most of my ancestry is what I expected, but oh, look at this, like 2% is wild. I had no idea that I had ancestors from, Guam or Madagascar or the Falkland Islands, some exotic place. And then what happens is that Ancestry adds lots more people to their databases, and they discover these genetic markers that they thought told you were 2% from, say, Madagascar. No, it's people in Germany, say, have it too. And so so they said, hey, we're updating your results. And they thought this would be great, and a lot of people were upset because all the cool stuff went away. And people felt like they were boring. And so, again, that's because we put so much stock in the past and what we look at in there to define ourselves. And even if you get an accurate result, just remember, saying that you're, say, Spanish. Let's say you discover you're 100% Spanish, okay? That's not like saying I'm 100% nitrogen or something like that. Spanish is not some timeless thing. To be Spanish is a product of history. There weren't human beings in Spain until about 45,000 years ago. And you're not actually, if you are Spanish, you have no connection to those people who showed up in Spain back then. You just don't. They disappeared. And what's been amazing in recent years, and I write about this in the book, is that scientists can get DNA out of ancient skeletons going back thousands and thousands of years. And I actually just recently wrote about a huge study on the Iberian Peninsula where they were able to find DNA going back about 8,000 years in all these different places, all these sites across Spain and Portugal. And if you look at it, you do not sort of see everybody's got the same genes and they've always had the same genes. It's a history. And if you go all the way back to about 8,000 years ago, you are finding a group of hunter-gatherers who are related to people who were there probably in the Ice Age. And they get pretty much replaced by people from Turkey who show up with crops. These are the first farmers. And then the hunter-gatherers come back for some reason. No one really knows why. All of a sudden, around 4,000, 5,000 years ago, you get a lot more hunter-gatherer ancestry in people. This is when you're looking at people who lived at these times. And then this yellow thing here, this is pretty wild. These are crazy nomads originally crazy nomads from Russia, who swept into Europe and then settled down, and people with their ancestry eventually moved into Spain, and they actually came to take up a lot of sort of the genetic ancestry of people at that time. And then a lot of other people show up. People are showing up from North Africa. There's a regular traffic from North Africa. Even 5,000 years ago or so, you get people showing up from North Africa. And the Roman Empire the Muslim reign, the Christians coming back in. It all is bringing in new DNA into this one peninsula, mixing it up. And so if people look at the results and say, oh, it looks like I'm Spanish, there's a much bigger, much more interesting, much more complicated history behind it. So we shouldn't look at DNA as somehow trying to simplify our past, but actually opening us up to amazing stories, a lot of craziness, a lot of chaos, which is what being human is all about. And that's one reason I love this movie, is that it just shows you just how, as much as we try to sort of figure out who we are, it's the craziness of the lives as we're living it that actually really matters. So thank you so much, and I hope you enjoy the movie. And as Beth said, I'll be hanging around afterwards and happy to talk or sign books. Thank you very much.